Hello class, today we are starting chapter 6, which focuses on systems of linear equations and inequalities. Today's lesson is 6.1, which is graphing systems of equations. By the end of today's lesson, you will be able to identify the types of systems of equations, as well as be able to graph them to find solutions. Systems of equations are sets of equations that have the same variables. So that's going to be 2, 3, 4, etc. equations that all have the same variables. For our purposes right now, we are only going to focus on 2 equations, but when you get into high school and into Algebra 2, you could be focusing on 3 or 4 at the same time. The solutions to these problems are written as ordered pairs, so we're going to be focusing on variables x and y. One type of system of equation is called inconsistent, and this is where the system has no solutions. What this means is that those 2 lines, when graphed, are never going to touch. This is another way of saying that they are parallel. Consistent is a system of equations that has at least one solution. There are 2 different types of consistent systems. The first is independent, where the 2 lines in the graph are going to touch exactly once. And the second is dependent, where the 2 lines are going to touch over and over. This is another way of saying it is the same line drawn twice. So it's going to be the same line given 2 different ways in terms of equations. This chart right here, which you can find on page 333 in your book, exhibits what those graphs are going to look like. So that first one is consistent and independent. They touch exactly once. The second one is consistent as dependent. You can see there's only one line. What you can't see is that that red line is directly underneath the blue line. So it's the same line, 2 different equations. And the last one is inconsistent. They are not touching at all. So part of your homework tonight is going to be identifying the different types of systems. So question number 1 asks us to look at the green line and the purple line. If we look at those, they are touching, so we're going to call that consistent. Yes, you may abbreviate. And it is independent because they touch exactly once. Go ahead and try number 2 and number 3 on your own, identifying the types of systems. Number 2 looks at the red line and the blue line, which touch exactly once. So that is going to be, again, consistent and independent. And then the last one asks us to look at the red line and the green line, and those 2 do not touch, so that is an example of an inconsistent system. Again, yes, you may abbreviate for those. Then there are some times where it's not going to give you the graph, so you are going to have to graph it yourself. Remember, when we are graphing, we want to look for y equals mx plus b format. These equations, both already have that format, so we can start graphing. We start at our b value, which is 10, and then we use our slope, putting it over 1 to turn it into a fraction. We go down 3 and right 1. And then you are going to draw in your line, making sure you are going all the way through the graph. This becomes extremely important with this lesson because we are looking for where those lines intersect. So it is extremely important that we have the line going all the way through the graph because we don't know where they're actually going to connect. Next one, we are starting at our b of -2. We can put in our slope of 1 over 1, so that's up 1 and over 1. And again, we are going to draw in our line all the way across the entirety of the graph. So now what we are looking at is to see, first off, are they consistent or inconsistent? So this is consistent because the 2 lines intersect. And then, since it's asking us to solve, we are actually looking for that point of intersection. Now, when you are graphing, there is going to be some error, so it might not intersect at a perfect point, but you want to make sure that you are rounding to the nearest point. So that green point isn't exactly on a point, but it is close to 3, 1. So 3, 1 is right there. It's pretty close, so we can go ahead and say that it's at 3, 1. When I am grading these both on your homework and on your test, I will give you a plus or minus 1 in either direction. So for example, if you had said 4, 1, I would have accepted that answer, or if you would have said 3, 2, I would have accepted that answer. So there are some variations that you can do and still get the answer correct with graphing. Go ahead and try this one on your own. So we graph the first line, and that is the one with the red dots up top. The second line is the blue dots down at the bottom, and our point of intersection is roughly at -6, -3. Again, for the x-coordinate, you could have had -7, -6, or -5. For the y-coordinate, you could have had -4, -3, or -2. Any combination of those numbers would work. Sometimes when we are graphing, we need to solve the equations before we can graph them. So this first one, we're fine. We can start at -3 and then go down 2 and over 1 and draw in our line there. The second one, however, is not in y equals mx plus b format, so we are going to need to rearrange that to get the y by itself. First step is subtracting 6x from both sides. So I end up with 3y is equal to -6x minus 9. And then I'm going to go ahead and divide everything by 3, making sure when you are dividing that each of the separate terms is divisible by 3. So we got y is equal to -2x minus 3. Now, if you look back at the first equation, I would put my points in the exact same spot, which would give me the exact same line, which means this is an example of all solutions. So 2 different equations giving you the exact same line on the graph. Go ahead and try this one on your own, making sure that you rearrange for y before you graph. So when we solve the first one, we get y is equal to 2x plus 1, starting at 1, going up 2 and over 1. That gives us the green line. And then the second one, when we rearrange, is y is equal to 2x minus 3, and that gives us the blue line down at the bottom. Since these do not touch, they are inconsistent, which means there is no solution to these. If you have questions about the all solution, no solution part, please let me know when you get to class. Last one, word problem. We got Joe and Josh each want to buy a video game. Joe has $14 and saves $10 a week. Josh has $26 and is saving $7 a week. How many weeks until they have the same amount? So the first thing we need to do is write 2 equations. We're looking at Joe and we are looking at Josh. So for Joe's equation, we need to figure out which one is the y-intercept and which one is the slope. Because it says $10 a week, that's the same thing as per week, so that's going to be our slope value. So we got y is equal to 10x plus $14. And then for Josh, similar kind of situation, except for he is saving $10 per week and has $26. So now we got to come over and look at our graph, and we want to make sure that we're going to have enough room on our graph to fit to find a point of intersection. So since our y-intercepts are bigger, I'm going to go ahead and go up by 10s. Wanting to make sure that we give ourselves enough room to find that intersection point. So our first graph starts at 14, and we're going to go up 10, which is only one space, and over 1, remembering that our x-axis has not been relabeled. And our second one, we're starting at 26 and going up 7, so not quite one full space, giving us our second point. Then we're going to want to draw in both of those lines. Since we know we're going to intersect somewhere in this first quadrant, you don't have to draw that line in on the other side of the axis. So we've got our 2 lines. And we are looking for our point of intersection, which looks to be right about there. And it's asking us for how many weeks. So this is when we need to pay attention to our axes. Going up and down on the y, that's the dollars. So going across on the x is the weeks. So we're looking for an x value here. So when we are looking at the x value of this coordinate right here, we've got x is equal to 4. So it's going to be approximately 4 weeks until they have the same amount of money. If you have questions about this or anything else from the lesson, please let me know when you get to class.